All right, welcome everybody. We have another one of the lovely Android meetups this month. First of all, thanks to all the people at Square that made this happen. We're really excited to be back here. I think we did one a couple of years ago, actually, but it's been a while that we haven't been back here. And it's always great to have Square speakers share some of their knowledge. We all know how notorious they are in the Android community. So tonight we have a slightly different format. We have three shorter talks, and I'm not going to go over the topics. You probably looked at the short description first. I'm going to let the speakers shine, but I just wanted to mention that this month is special for us for the Android meetup because we have not one but two meetups this month. We have another one next week at Instagram, which is going to be really exciting as well. So make sure you stay up to date with the meetup page. All the information is there. And yeah, stay tuned. And with that, I'm going to leave it to Zach for the first talk.
I'll take it away. I'm not Zach. Welcome to Square. I'm Ray Ryan. Zach and I are going to talk to you about a library that we've just open sourced called Workflow. And there's going to be a little bit of slides and a lot of live coding because he's much braver than I am. And we will see how it goes. So very briefly, we started working on this a couple of years ago. You might have seen some of our DroidConf talks about this because we have a basic problem with our app on both Android and iOS that it was kind of sprawling. We've got, last time we measured like 450, 470 individual screens on these apps. And we've been a pretty disciplined MVP type of shop, but you wind up with a problem where presenters are really convenient and all of the code winds up in presenters and the individual navigation decisions get spread all over the place and become impossible to maintain and everybody gets scared and sad. So our flow is typically something like, I'm going to take an order and build up my cart, and I'm going to charge a credit card, and then I'm going to give somebody a tip, and I'm going to have to sign for this thing, but sometimes I get to skip the tip screen and I go to the signature screen, and after that we go to the receipt screen, except I might be skipping the signature screen as well, or I might skip both screens and go straight to the receipt screen, and then everything has to be able to get back to the cart screen and so on. And it's not a whole lot of screens there, 5 of them, but it gets out of hand quickly, and we have hundreds. The code for stuff like this winds up looking something like this, where our charge screen has a nice if cascade of where to go next, and the chip screen has a similar cascade. And if you look, you can see that half the cascade is really kind of identical. And you can do better than this, and you can refactor things and get them together, but it requires discipline. And if you look back at the little the transition graph I put there, it kind of looks like a state machine. And we realized that what we really wanted was a way to just put a class around all of this stuff and make the state machine actually a state machine. And so that's what we set out to write for ourselves. And it went pretty well. We've been enjoying it. We measured and shocked ourselves to learn that something like 30% of the screens in the app that we're shipping right now are using one of the various versions of the Workflow API that we've worked through. But we did notice about 6 months, a year ago, that what we had accidentally done was reinvent React, except not as well. So we went through one final rewrite where we very intentionally reinvented React goodly instead of poorly. And that is what is up on GitHub right now, and we're just quietly getting ready to draw attention to. So I'm going to give you a kind of a quick look of what the moving parts are so that you're grounded for Zach's daredevil stunts, and then I will hand over. So the main thing at the heart, we have a workflow interface, which is how you actually describe the state machine, the actual modeling of the logic of individual screens, and most important for us, the navigation between the screens. Workflows emit a series of renderings. We would have called them view models, but Android took that, so now they're renderings. And these are just simple data classes, simple structs. I would have put data there, but I was trying to conserve screen real estate. In this case, if we're on the new game screen, we're not in a payment app anymore, we're in a games app now. And all this one has is a little event handler. When somebody says they want to start the game, they'll give us 2 names of the players and off they'll go. And then we also provide a convenience interface called Layout Runner, which is a very, very minimal amount of work needed to do to take a view instance and provide a show rendering method to actually update it with what you want to have on the screen. So between the rendering with its little onStart event handler and whatever data you needed to put stuff on the screen, and your layout runner with the layout that it's running, and a callback to onStart, you have your unidirectional data flow, like React has taught us to love because they were right. One thing I want to make sure that we remember to say is that the layout runner portion of this is orthogonal and optional. We've kept the very strict line between workflow and layout runner. They don't actually know about each other. So the compose library that was just announced, we're actually thrilled with that because this should play nice with that. The other thing that I didn't mention is that this is both a Kotlin library and a Swift library. We're not promising, cross-platform or anything like that, just 2 parallel implementations with consistent documentation, consistent API. And we have started playing around with Workflow Swift and Swift UI, and that's been pleasant also. So that's what I've got. And now, no net.
All right. I'm Zach. And I will probably not be using this mic because I can't hold it and type at the same time. If I talk really loud, can everyone hear me in the back? Awesome. Here. Okay.
I have a mic stand.
All right. So can everyone see this code? If not, there's also a screen in the back. So I don't know if there's speakers back there. So, someone wants to just go repeat everything I'm saying on that end of the room. All right. So all right, so we're going to write a to-do app, or a very simple to-do app. It's going to have, we're going to start with one screen. It's going to have, well, why don't I just show you? They've got it running here. Looks something like this. So very simple. You can check things, and eventually you'll be able to delete things. You got a title. So we're going to write this with workflows. So we've got one workflow. The entire thing is run by one workflow right now. So we need a couple of things. We need to have some state, and we need to have some rendering that we can actually spit out to the screen. So our state, we've made this to-do list data class. It just has a title and a bunch of rows. And a row is just some text and a flag that says whether or not it's been checked off. So here we've got our workflow. It's a stateful workflow. There's also stateless workflows, which I'll try to show at the end real quick if we have time. So you'll notice there's 4 generics here. 2 of them we don't care about for this right now, so I'll just highlight the ones we do care about. This one is the state. So it's a to-do list, as we said. This last one is the rendering type. So that's what we actually spit out as the screen data, or the view model, screen model, whatever you want to call it. Right now, they're the same thing. So inside of the workflow, we have 3 methods. The first method is that when the workflow starts up, we need a way to say what the initial state is. So we're given a couple of things here that we're going to ignore, and we just hard code it to a basic to-do list, just so we have some data to show. The second method here, render, this is the heart of any workflow, and this is called multiple times throughout the lifetime of the workflow. And it gets a couple of things. It gets this input, which is not like text input or whatever. But so we can just ignore that for now. We get the current state and this context thing, which I'll talk about in a second. So the most interesting part is the state. We don't have any. You'll notice we don't have any like properties or fields or anything like that. All of our state is stored in this in the state thing, and it's all like immutable. So the only way we can like update our state is by performing actions that change the state. So we don't do any of that yet. We'll do in a second. So for right now, all we do is we spit out the state. We copy it first of all and add an extra blank row at the bottom, so that if we run this from scratch,
we didn't QA a whole lot.
There's this new item thing at the bottom here. So eventually that'll allow us to add new items. So before we start typing, let's look at one other piece, which is the layout runner that Ray talked about. So this is what actually binds the data to the actual view. So there's a couple interesting pieces here. We've got this view binding at the bottom, and this says what Android XML layout file to inflate for the screen, and it tells it to use this layout runner. It also includes the type of the rendering that it's going to use. So we use that to, when we get a rendering, we can look up all of the bindings that we have and say, okay, which runner do I use? Which layout do I use for this particular type of screen data? So our layout runner class has the same type on it. It gets a view, which is the inflated view. And then it can do some view bindings, very standard stuff. And then it has this one show rendering method, which gets the actual rendering and can do whatever it wants with that, bind it to the view. So we just do things. We just set this title, and we set some rows. So this item list view thing, it's not an actual list view, don't worry. It's basically just a linear layout, just for simplicity for this demo. But in a real app, it would probably be like a recycler view, and you can imagine the rest of the details. So we just like map the to-do list rows. We just pull out the booleans and the text and send them to that thing. So so this is cool. It looks like kind of like a to-do list, but we need to have some events here so that we can actually do something with it. So let's add some events. So this item container has a couple of event handlers we can set. So we are going to set all three of them. So we need to do something when you check a box, and we get the index of the to-do item that was checked. And when the text changes, we get the index and the new text. And when you delete an item, you get the index. Okay, cool. So now we need to send those to the workflow somehow. And the way we do that is through the rendering. So we need to add some event handlers to the rendering. So we don't really want to add them to the to-do list because the event handlers aren't really part of the data model. So we will make a separate rendering type. And this is pretty common. The rendering can either be like a kind of a view in the database view sense of the state, or it can just wrap it and include some extra stuff. So we're just going to wrap it and have a to-do list inside of the rendering and a single event handler. And we're going to make a seal class to represent our event types. So we're going to call that to-do events. How am I doing for time?
I have no idea.
So we're going to have 3 events. We're going to have done clicked, which is just going to take an index. We're going to have text changed, which is going to have an index in the text. And we're going to have delete clicked. So those are the events we can handle right now. Now we've got typed events. We know the rendering. We know all of the events the rendering can accept. So now we have to use this rendering type. So we're going to take this rendering type and use that for the workflow. It's complaining that we need to return the rendering from render. So let's do that. And that's complaining there too. So let's create a to-do rendering. And we've got our list. And we need that event handler. So I mentioned this context thing earlier. So this does a couple of things. This lets us handle events. It lets us compose with other workflows and run other asynchronous kinds of work. So I'm only going to look at the one of those things for now, which is events. So we can create an event handler with onEvent, which has an event type. It accepts some data. And we give it a lambda. And so this lambda gets the event in and then returns a workflow action. And the workflow action basically says which state to transition to when the event happens. It can do some other stuff too, but we'll just focus on the state for now. So, and this onEvent, if you look at the signature, it returns a function that doesn't return anything and just takes the event in. So this is something that we can just put in the rendering, and then we can call that from the UI. So we're going to have to handle all 3 event cases. So we can have IntelliJ just add that for us. All right, cool. So now let's just go real quick before we fill these out. Let's go back to the layout runner and fill these in. So so this layer render has to match the rendering type of our workflow. Otherwise, we'll get a runtime exception that says like, oh, there's no rendering for this, or there's no binding for this rendering type. So let's drop that rendering in all the 3 spots. Cool. And now we just have to add this list. All right, so now we've got our to-do rendering. And this is generally a good idea, even if you're not adding event handlers, because the state is technically a private concern. When you're composing other workflows and stuff, I don't care what my child workflow state are. If they have state or not, doesn't really matter to me. That's a private concern. So it's always nice to have that separation. Basic, programming best practices. So now we need to forward these events. So done clicked for this one. This is all like pretty mechanical. And there's another way that you can do these events. So we have one event handling function. You can also do it where you have like a different event handling function for each event, or maybe you have nullable event handling functions if you've got events that are only accepted in certain cases, and like maybe you've got a button click that you only want to handle button clicks in certain states, and so you want to disable the button sometimes. So you can just have a nullable event handler, and your layout runner can say, oh, if the event handler is null, that means I can't send the click event to the workflow, so I can just disable the button in the UI. So you can do kind of 2 things at once there. So all right, so now we've wired up these event handlers. When something happens in the view, we send the rendering the appropriate event with the right data. So that's it for that. So let's go back to the workflow. And let's actually run this real quick and see what happens. So right now, if we do anything in the app, it should crash right away. 4 minutes.
Now we get to watch our build time.
Yes.
We thought about talking about Bazel here, but that didn't seem like a good use. Still building.
Yeah, all right, cool. So let's try clicking something, and boom. All right. Never been so happy to see an exception before. So how do we actually wire this up? So let's wire up this check. No, it's not there anymore. But let's wire up the check event. So what we want to do when someone clicks a checkbox is we want to change state. So we're going to say enter state, import that, and then we want to take our state and copy it. And so we've got title and rows. So we want to change the rows. And data classes are great for this because you can just make copies really easy and update parts of them. And we want to do here is toggle a flag on one of the rows. So I'm going to take the rows list and do a map. And I'm just going to, actually what I want to do is map index. We get an index and the row. And then I can just say if index is the index that the event got, then we want to copy the to do and set done to, we want to toggle the done flag. And other rows we just return directly. So there's a bit of like functional list processing here, but normally you would like factor this out into like a state dot update row function or something like that. So this just mutates the one row. We return it. So that should be it. So and then we pass that to enter state, which means that we are now going to get another We're now going to get another render call right away that with that new state, and we can spit out another rendering with a new set of event handlers that all have captured that state value.
So we have the demo that we're running here is one that we've actually put up on our GitHub repository in our samples. It's our 4th sample. We're very proud that we wrote any samples. And there's incremental commits along the branch of the initial hello world state of it, the display only state of it, the single screen state, and then finally some backstack navigation, which hopefully will be digestible.
So yeah, so now we've got checkboxes at work, and we can even rotate, and without doing any complicated stuff, we've already got state that lives between activity restarts. So since I'm running out of time here, I am just going to check out some stuff real quick. I'm gonna do it from the command line. So you can see here in the prefab version of this, I have factored out some functions. This is our good old fashioned on event here. So when you click done, we update a row. We toggle the flag. When you enter some text, we update the row, change the text. And when you click delete, we just remove the row. And I'll let you read this code, after the talk if you want. So this gives us a full editing. We can change the text, we can delete rows and stuff, and it all gets stored in this. We're not persisting this anywhere yet, but it's all there. So, and right before I run out of time, I have like 1 minute left. I'm real quick going to, that works, cool. And so now I've got an app. I can edit the text in it, cool, and I can delete rows. Sweet.
Add rows?
I can add rows too. So let's run this. Hit run. Okay. Oh, there it is.
So I spent all my slides talking about how this helps with navigation, which we of course carefully not actually shown you in the live coding. But we did implement the navigation with less code than you saw, and it looks like this on the app.
Yeah, it's in one commit. It's pretty brief. Check it out on GitHub. We'll send the link out. But now we've got screens. I can go add. I can add groceries. I can check them off. I can delete them. I can even edit the title. And I can go back and it updates there. And this is all unidirectional data flow. And the navigation is actually really nice. There's no explicit navigation specified. It's all just like, oh, I need that. I have another rendering type and I've got another workflow that's going to produce it. And it just all works. So yeah, I think that's all we had to say, really. Yeah, we'll send the link out to the code for this afterwards.
And we'll answer questions afterward, but we don't want to leak into Pierre's talk. Thank you. Thank you.